Lecture video will be about preparation of aldehydes and ketones. Before discussing the preparation of aldehydes and ketone, first we will know about the carbonyl compounds. These are the organic compounds like aldehydes, ketone, carboxylic acid esters, anhydrides, acid halides, amides that will contain the carbonyl group. So it will have some common group that is known as carbonyl compound. Now, what is carbonyl group? A carbonyl group is the functional group which is composed of carbon atom that is doubly bonded to the oxygen atom. So, the carbon atom, when it is attached to the oxygen atom through double bond, this will produce a carbonyl group, that is the functional group. Ketone and aldehyde. What is difference between ketone and aldehyde? So in case of ketone and aldehyde, both have C double bond O, that is carbonyl group. But in case of ketone, two alkyl groups or aryl groups are bonded to the carbon of the carbonyl group. So here it is ketone because there are two alkyl, or it may be aryl group. In case of aldehyde, one alkyl or one aryl group is attached to the carbonyl carbon, while the carbonyl carbon is attached to the other side with hydrogen. So it will create another group that is known as CHO. CHO, this blue group, it will be known as formyl group. So C double bond O, this is the carbonyl group, while the CHO, it is the formyl group. Formyl group is the functional group of aldehyde, while carbonyl group is the functional group of ketones. Symmetrical and unsymmetrical carbonyl group. If two alkyl groups of the carbon containing the double bond with oxygen, that is the carbonyl group, are same, then it is the symmetrical. So these both are same, whether it is methyl, so both will be the methyl. If it is ethyl, then both will be the ethyl. It is symmetrical carbonyl group. In case of unsymmetrical carbonyl group, so here it is R dash and R. So R dash is different from R. If it is methyl, then it will be the ethyl group. So if these both different groups are attached to the carbonyl carbon, then it is unsymmetrical. In case of aromatic aldehydes and ketone, if the aryl group or aromatic ring is attached to the aldehyde group, that is the formyl group, it is known as aromatic aldehyde. While the R group, whether one R group or both the R group are replaced with aromatic ring, then it will be the aromatic ketone. So these both are the examples of aromatic ketones. Preparation of aldehydes and ketone can be done through different methods. So some of these methods are discussed over there. Ozonolysis of alkene, hydration of alkynes, oxidation of alcohol, and friedel acylation of aromatics. First method is ozonolysis of alkenes. Ozonolysis means the reaction of ozone with alkene. So ozone reacts vigorously with alkene to form an unstable intermediate compound that is known as ozonide. The ozonide is reduced directly to aldehydes and ketone by zinc and water to produce aldehyde and ketone, and the reaction is known as ozonolysis. So there are two cases given. In case of symmetrical, alkene produces single product, while unsymmetrical alkene produces a mixture of aldehydes and ketone. First, we will discuss about the cis and trans. Cis and trans. In case of cis, the bulky group are attached to the same side of the double bonded carbon atom. So this will be the known as cis. In case of trans alkene, the bulky group, that is the methyl group over here, it is attached to the opposite side of the double bonded carbon. So this will be the trans and this will be the cis. So we will discuss their reaction with ozone. In case of cis trans, ozone will react with it and it will produce a mixture of aldehydes. Only aldehydes are produced, whether it is cis or trans. It is given over there. Symmetrical 2-butene, this is the symmetrical 2-butene, both cis and trans give only acetaldehyde, or we can say it will produce only the aldehyde. While asymmetrical 2-methyl 2-butene yield a mixture of acetaldehyde and ketone. So in case of asymmetrical, so when ozone react with it, it will produce 1 mole of aldehyde and 1 mole of ketone. Both the aldehyde and ketone in the mixture are produced, while in case of cis and trans symmetrical compounds, it will produce aldehyde. The mechanism is given over here. The molecule of ozone, it will attach itself to the double bonded carbon atom and it will produce ozonide. So this molecule is ozonide. Ozonide, in the presence of zinc, water, it will split the bond at this side and this side. It will produce here this O, oxygen will react with zinc and it will produce zinc oxide. Methyl and CHO, that is the aldehydic group, so it will produce 1 mole of aldehyde, and here it is methyl and CHO, it will produce another molecule of aldehyde. So 2 molecule of aldehyde will be produced in case of symmetrical, while in case of unsymmetrical alkene, it will produce aldehyde and ketone both. Hydration of alkyne. Alkyne undergo acid-catalyzed addition of water across triple bond in the presence of mercuric sulfate as catalyst to produce carbonyl compound, either ketone or aldehyde. So acetaldehyde or ethanol are produced from the ethine or acetylene, while ketones are produced from the higher alkynes. In all these stepwise process, there is the production of unstable enol that will undergo tautomerism and it will produce aldehydes and ketones. Mechanism will be discussed. So first is the electrophilic addition of mercury ion. So the mercury ion having the positive charge, it will combine with the triple bond or pi electrons of the carbon triple bond carbon, and one of the triple bond is break, so it will produce positive charge on the other carbon. Second step is nucleophilic attack by water. So the water has oxygen has lone pair of electron, so it will attach itself to the positive part of the molecule that is produced in the first step. So it is attaching itself to the positive part. Third step is the deprotonation step, which means the removal of proton. Water molecule, it will remove the proton from already attached water molecule in order to stabilize the positive charge on the oxygen. As a result, the hydronium ion will be produced. Fourth step is the substitution step. Substitution step, the hydronium ion containing the hydrogen ion and water molecule. So the hydrogen ion having positive charge, it will substitute the mercury ion having positive charge. So H ion from the hydronium ion will attach itself over there and the mercury sulfate will be released. Also, the water molecule will be released because the hydrogen ion is attached itself to the molecule and it will produce enol. Fifth step is the tautomerism, which means that the enol molecule will undergo tautomerism and it will produce either aldehyde or ketone. Third step is the oxidation of alcohol. Oxidation of primary alcohol with strong oxidizing agent like acidified chromate, dichromate and permanganate solution leads to the formation of carboxylic acid as final product. So when we treat alcohol with these reagents, it will produce carboxylic acid, although the aldehyde is the intermediate. So there is a sketch given. Alcohol when treated with or when it is oxidized, it will produce aldehyde, and aldehydes are further converted to the carboxylic acid when it is treated with these reagents. Aldehyde here is present as intermediate product. However, good yield of aldehyde can be produced as oxidizing agents such as PCC. So when we treat the alcohol with PCC, it will produce aldehyde and it will not undergo further oxidation to carboxylic acid. So primary alcohol, it will produce aldehyde, while secondary alcohol, it will produce ketones. So here this is the oxidizing agent, oxygen from oxidizing agent, and this will be the primary alcohol because here the OH is attached to that carbon which is further attached to one alkyl group or one carbon atom. So when it is treated with oxygen, it will produce aldehyde. So this is the reaction, or this is the mechanism over given. This H and this H from the primary alcohol, it will react with oxygen from the oxidizing agent and it will produce water, and as a result aldehyde is produced. If it is treated with these reagents, then it is further converted to carboxylic acid, or if we treat it with PCC, then the aldehyde will be the final product. In case of secondary alcohol, it is oxidizing to ketone. So in case of secondary alcohol, this H from the carbon containing alcohol and this is the H hydrogen from the alcoholic functional group, these both will attach, or these both will combine with oxygen from the oxidizing agent and it will produce water, and as a result ketone or propanone is produced. Tertiary alcohol do not oxidize. There is a condition for oxidation of alcohol that it should contain hydrogen with carbon that is attached with the OH group or the functional group. So in case of tertiary alcohol, there is no hydrogen present over there, so it will not oxidize with normal oxidizing agent. Friedel acylation of aromatic compounds. So benzene, when react with acid halide or anhydride in the presence of Lewis acid catalyst, and it will produce aromatic ketones. Benzene, in this case, it will react with acetyl chloride in the presence of aluminum chloride and it will produce acetophenone. So the mechanism of this reaction is very simple. This aluminum chloride will trigger the reaction. It will break the CH chloride bond, carbon chloride bond, and it will produce AlCl4 minus. So this bond will break and this chloride will attach itself to the aluminum chloride and it will produce aluminium Cl4 minus. It will produce electrophile, so it will contain positive charge. This carbon will contain positive charge. This electrophile will attach itself to the pi electrons or pi bonds of benzene ring and it will produce aromatic ketones. The mechanism discussed over here. So first this bond will break by the aluminum chloride and aluminum chloride AlCl3, this is the aluminum chloride, and it will attach itself to the chloride from acetyl chloride. It will produce AlCl4 minus. And it will result electrophile. So this electrophile will attach itself to the benzene ring and it will produce the aromatic ketone. So this reaction will fast, so it will attach itself to the benzene ring. As a result, the hydrogen from the benzene ring will release. When it will release, it will combine itself with chloride that is already attached with the AlCl3 that is removed from the acetyl chloride. So HCl, hydrogen chloride, will produce an aluminum chloride which acts as a catalyst. It will release. So this is the simplest mechanism of this whole process, that aluminum chloride will trigger the reaction. It will produce electrophile. Electrophile will attach itself to the benzene ring and the benzene ring will remove the hydrogen ion. A hydrogen ion will attach itself to the chloride that is released from the acetyl chloride, and the aluminum chloride will release at the end of the reaction that act as a catalyst. So this is the simple mechanism for this process.